On behalf of Web-Based Solutions, I would like to welcome you to our today's webinar, Introduction to DevOps. My name is Mikhail Vladimirov. I'm with Web-Based Solutions, a consulting and training company based in Toronto. Web-Based Solutions provides a broad range of regular and customized training classes in programming, system administration, and architecture to our clients across the globe. In today's webinar, we are going to talk about the DevOps discipline and tools supporting this practice. And for today's webinar, here is our agenda. So we will try to define DevOps. We will also provide a quick overview of some of the common tools used by DevOps. You might have a different opinion, you might have a different tool set, but we will touch on those which are the most popular with the DevOps community. We will also provide a very quick overview of IBM tools for DevOps. IBM has been very active in the enterprise space with the tooling support for operations and development, and quite naturally they are joining this crowd and trying to get some piece of action. IBM is very good at making tools for the enterprise. Of course, it comes at price, and we would contrast some of the tools possibly with some of the open source tools available out there. The way we want to go with this webinar is I would like to hear your feedback, your questions right away. So you can put your questions in the questions pane that is, again, part of the GoToWebinar console. Just put your questions in there and I will attend to the question as I go. If it takes longer, then I'll put it off until the Q&A session that we will have at the end of the presentation. It will take me probably about 45 minutes or so, and we will have 5 to 10 minutes for Q&A. Some people might want to ask the slides. I provided a link in the chat window. That's the link where you can download the slides deck that we are currently going through. Okay, so let's get started. So let's try first to define DevOps. And probably the best way would be to start looking at some existing antagonism that exists between development and operations groups. So this slide presents this in a kind of a exaggerated form, the view Dev and Ops have of each other. Yes, Jay. So the link is in the chat window. So if you click on the chat link, it's at the bottom of the GoToWebinar. You would be able to see it. If you don't see it, let me repost it again. Okay, it looks like people finally got it. I duplicated it, and I'll do it again. I broadcast it to the entire audience, so I don't filter out anybody. Okay, guys, looks like very good. So, as I said, it's a little bit of blown out of proportion, but this slide is used to just highlight some of the points or descending views of the software product that DevOps is trying to push out to operations, and operations is only concerned with the integrity and stability of their environment. So on the left-hand side, in the left-hand column, you see that Dev is pressured by business, and business is really churning out the software, and Devs is of the opinion that operations are not very good in supporting them in those initiatives. Sometimes you might have very absurd arguments from both sides, but pretty much it boils down to different views of software delivery. And the best way to, I guess, mitigate those differences and maybe create a collaborative view of software as a product is to join at least some of the aspects of development with operations. So this slide, which is I borrowed from Scott Adams' cartoon strips catalog. It's very descriptive slide. Whenever it comes to adopting a new discipline, a new technology, you can use this slide because it fits in the mentality of some of the executives who would like to maybe see things just because they are all the hype, they are in vogue. Whether it comes to SOA, whether it comes to cloud, big data, same story applies to DevOps. So let's implement DevOps so that I have something to talk about at the executive meeting. And eventually, if that is the approach, that's kind of just let's adopt a particular thing because it's just all the rage, it's a recipe for disaster. You really need to be aware of the repercussions and what is involved in a particular technology or a particular paradigm. So DevOps, as you know, I probably be preaching to the converted, but let's start from square one. DevOps is a contraction of development and operations, but it's not really all inclusive, and it doesn't really cover all the aspects of DevOps. It's just an abbreviation as one of those monikers or labels that we are so fond of. We like those short things that we can use as a lingo or professional jargon. DevOps, it's an approach. It's a culture. It's a cultural thing, I would say. It's a discipline of delivering software solutions in a continuous manner. It's very important that it's not ad hoc, it's not sporadic, that we would do the build and we would strain our resources. It's just something that has been established, and it's a continuous software delivery pipe. DevOps is trying to pursue those deliveries based on the lean and agile practices. So lean is about minimizing wastes, cutting down on unnecessary activities, minimizing bugs, and doing it in an agile manner. DevOps, among many other things, help manage complexities. It just has been popularized in order to create a collaborative environment where you would overcome those hurdles and barriers between different groups, particularly between development and operations. And that collaborative environment can be anything. It can be just, I guess, a contact group, or it can be organizational unit within your company with a single reporting line. It depends. There's no hard and fast rules for that. You should develop a model which best suits your organizational structure. But what's important is that in addition to development and operations, in that representative group should be representative of business, quality assurance group, and other stakeholders who might want to have a say. Of course, it shouldn't be kind of a 7 cooks who would spoil the broth, but it should be collaborative environment with the sole focus on ensuring uninterrupted delivery of software. DevOps practice in the present form has been popularized by those companies which have their business based on the cloud, such as Netflix, Flickr, and they have realized the potential of the modern technologies such as cloud, maybe containerization tools, which we are going to talk about shortly. And some of the infrastructure as code models that, when joined together, create a new sort of a holistic view of software as a product. And this is has been proven in production at deploying large-scale systems where deliveries count in tens, if not hundreds, per day. And definitely, if you don't have this continuous delivery pipeline, then you are in trouble. And I guess some of those, not all of those practices and techniques should be adopted, but at least the best practices. And whether you are an enterprise, a very conservative environment like insurance company or bank, or maybe startup companies, you can find tools and techniques that are suitable in your environment. So DevOps is about shortening the application delivery lifecycle, making increasing the velocity of the application delivery and making it predictable and making it efficient. So as you noticed, those 4 bullets equally split between the responsibility or main concern of development group, such as development and testing, and operations, which are deployment and operations. And you cannot really ensure a successful delivery of a product without combining this into one consistent application delivery lifecycle. So what are the objectives of DevOps? Continuous software delivery, planning and control. So software delivery is about probably change requests, probably existing project plans, and whatever drives software delivery, but those things should be governed. It's not something that you create a pipe and that kind of a garden hose or fire hose can churn out software at the speed of light. There should be some governance in place, and in many cases governance sits in the head of those people who are very disciplined, who are monitoring the whole system, but it's not the best practice. The good thing about it is that you've got the underlying infrastructure and you've got people who can do this. And sometimes what is missing is that governance check where you have the specific processes for change requests, monitoring of having the response feedback, and some other mechanisms for controlling that continuous delivery. So software delivery process optimization at every juncture of this process, whether it's testing, whether it's build. Sometimes you might have a bottleneck in your process delivery where the build machine, physical machine, is probably underrated and it takes forever to complete a build. And you would like to have a shorter cycle of build and quick smoke test and delivery to whatever target environment might be. So for that, you might use probably multiple build machines, and you just need to go through the whole chain of software delivery and find those bottlenecks and kind of apply that Six Sigma approach where you would minimize that time wasted at a particular point in the delivery of software. Consistency and predictability are other objectives. With consistency, you would be looking at having the same result. So whenever you do a particular build, it should be sort of idempotent. You would create the same thing over and over and over again. Your builds are repeatable. If you don't change anything else, it's the same code. That binary that would be produced by your build process should have the same checksum, should have the same size up to a final bit. Predictability means that you should have metrics to measure such parameters of your system as the build time, probably test time and smoke test and deployment. All those things should be known up front. And if you don't know those, you just need to run the test, get that measurement, and see and observe it over a period of time to make sure that it's consistent. Minimization of software defects, unnecessary rework, and that's what the lean aspect of ops is all about. I guess test-driven development, which is part of the concern of your development, should be in place. Also, testing of deployment scripts, of administration scripts is also important, where you would use the same script to promote your code to your system integration testing environment, your UAT, your probably acceptance testing, or whatever environments you might have, staging, and production. So the same script should be tested to promote your code, ensuring that it's consistent, it's predictable, and there would be no nasty surprises when you promote your code at 3 a.m. On Saturday. Software delivery lifecycle time reduction, again, it's part of that lean aspect of DevOps. Infrastructure as code, some people get confused. It's one of those as something model where you've got infrastructure as a service, you've got platform as a service, maybe failure as a service, you name it. But this label is, or this term is used to refer to this practice of provisioning infrastructure by executing administration scripts, where you have everything scripted, which would allow you to produce the environment in the state which you are after. Meaning that the system would have a particular folder structure, the system would have a particular application deployed at a particular IP address, and ports would be open for any external system to access that MySQL database on the port 3306 or what's not. So all those things should be scripted. Nothing should be left out to some defaults or some we'll go and fix it. It should be scripted. So that scripting aspect allows you to configure infrastructure inside your code. In many cases, under DevOps arrangement, development can be given system administration privileges to run those scripts, and in many cases, developers would act as testers of administration scripts. It speaks to reason that dealing with staging and production should still be the privileged activity totally owned by operations. So even though you have this communal nature of DevOps, there should be some maybe subtle but still existing separation of certain privileges, certain rights. Very few people from operations should have production passwords and things like that. They should know that backdoor URL and maybe some other details that development should not be aware. Otherwise, developers would definitely sneak in and they will fix some of the things on the fly to make them appear as a success. So infrastructure as code is effectively supported by tools such as Chef, Puppet, IBM, Urban Code, Deploy, and many others. Here is just a very short list. So here's an example of how you would use Puppet in this context. So Puppet is an IT automation tool which implements that paradigm of infrastructure as code. So in this three-step process, you ensure that the resource Let me highlight some of the points. Puppet, as well as Chef and other infrastructure as code systems, they operate on resources. And resources are like file, maybe user, maybe service or software package, application package. And you apply the state to that package. In this case, with file, we would like to create a file. So that ensure present property or attribute of the Puppet domain-specific language, which is written in Ruby, by the way. That's why you've got this equals less than sign. This is a property which would be interpreted by Puppet, by Ruby, to invoke a system-specific command to create the file if the file is not present. Or Ruby might use its own input-output library to create the file. So we specify the property for mode of the file to be created. So if file is already created, then you don't need to do anything. You would just skip that step. In this case, 640 means that, by the way, Puppet runs on the root account, which might be a bit of a security concern. But in this case, it would create that file specified by this location with read-write permissions for the root and read-only permissions for the root group and nothing for everybody else. You can also specify the content of the file. You can span multiple lines. So when you specify that manifest, that's the name of that of that file. Normally extension is .pp. So whenever you see that pp, it's not something that comes to your mind. It's actually extension reserved by Puppet manifests. And then you would run it. This is an example of how you would run Puppet locally on every machine. So you would apply that script that you saved as a manifest.pp or whatever name, create file. If you want to delete the file, you would just need to specify ensure absent. So when you apply that script at step 2, Puppet would go ahead and make sure that the file is deleted. Since you are root, you will be able to do that. You can execute Puppet scripts from command line, where you would inline your script, and you would just use that -e or execute script flag. Of course, you can start service, you can stop service as a resource, you can do lots of other things. With Puppet is really geared towards people who like that very succinct, very short scripts and very powerful. Chef, on the other hand, takes it slightly more lax approach. You would have an opportunity to really use some of the more elaborate constructs in Chef, but the principle is the same. So you use infrastructure as a service by changing the state using your code. Hopefully it makes sense for those people who are not familiar with that concept. DevOps in the cloud, as I said, DevOps was popularized and brought to fore by companies, organizations working in the cloud. Cloud computing as such can dramatically improve many aspects of your organization when you would like to have an agile platform which has that nature of elastic capacity with a built-in scalability and robustness that is given to you by your cloud vendor. But DevOps benefits probably the most out of that model. Developers and operations folks can easily self-provision the needed resources by just clicking buttons, going to the specific section whether you would like to work with virtual machines, maybe your storage, maybe messaging system, and you would create things that is of sort of a Visual Studio, whatever system you use, whatever cloud would be your target platform. Cloud platforms help DevOps in that you can replicate your environments. The snapshotting, when you can create a snapshot of your volumes and you can move them around between system integration testing, QA, acceptance testing, and move stuff into production by just changing some configuration files and using those scripts using Puppet, Chef, or any other system. Or you might use something that you would roll out on your own. DevOps on IaaS, infrastructure as a service. IaaS is giving you the lowest possible control of the environment. The most prominent players in this space are Amazon, Google with their compute engine, Microsoft Azure, and OpenStack, which is an open source cloud platform. So IaaS gives you everything that you might need to deploy your solutions. All those infrastructure assets as you might need virtual machines, which would become your servers, networks, load balancers, your volumes that you can attach, make a snapshot of and replicate, as well as a variety of storage solutions, which might be a relational database or NoSQL. And all those things can be provisioned quite easily. All those things are available. As long as you've got the license for a vendor-specific product, or if it's an open source, you would be able to get things and deploy it in a matter without incurring any additional costs. As long as you are ready to pay for CPU cycles and resources physically consumed by your application. So that's where, I guess, DevOps was really sprung to life. On IaaS, DevOps would be responsible for some of the administration aspects, even though lots of things just magically go away. You don't have any fixed costs. You don't need to buy physical hardware. Lots of things are supported for you, such as that if you have a problem on a physical layer and your virtual machine would not be able to run, the virtualization layer of your cloud vendor would make sure that that machine would be transferred to another functioning physical machine. It would be done transparently. There would be some hiccup, some delay. Probably it would be a matter of several seconds, maybe a minute, and that system would be deployed on a new physical machine. But still, DevOps would be responsible for patching operating system software, and perform some other housekeeping tasks like formatting those volumes that come as raw block storage, network attached. You would need to partition them, format and mount, making them available to your virtual machines. Also, security is still your burden. You would need to make sure that you know about system layering, partitioning, and you would be ultimately responsible for maintaining the access control list of those people who have access to a particular layer, as well as managing the virtual firewall ports. Normally they're bundled as security groups, and you would opening only those ports that you need, like port for SSH or maybe port 80, and closing all other ports. So by default, some cloud have all ports open, other have all ports closed. Just make sure that you know what platform you are in. On PaaS, DevOps has much less to do, and some of the popular PaaS platforms are Microsoft Azure, which is built on top of their IaaS platform, App Engine, Elastic Beanstalk from Amazon, Heroku, which were acquired by Salesforce to extend their presence in the cloud. Cloud Foundry and IBM Bluemix. It's a new addition to that space, and IBM is very active in this area. So if those people who are IBM shops, stay tuned, because IBM is very aggressive in pursuing that venue. As you know, a platform as a service gives you a choice of sandbox runtime environments. You can have Python, you can have Go, Google experimental language, you can have Java, Ruby, whatever runtime your PaaS platform can give you, as well as APIs for secure access of PaaS resources. And all those things are sandboxed. It gives you a runtime environment which is very limited in what you can really do, like in terms of maybe spawning a new thread of execution, or maybe performing a particular input-output call, which would be blocked because you wouldn't be allowed to interact with the operating underlying file system. But PaaS gives you a great deal of, I would say, leverage, where you would be able to push, scale, update your solutions on PaaS without much of a trouble or headaches. You would have the necessary dashboards where you would click on the buttons, and you would probably request some additional resources, but you are much more limited compared to what you can do on IaaS, infrastructure as a service. Containerization tools are all the rage, and people have started realizing that virtualization sometimes is not the best answer, because in the case of virtual machines, you would still, whether it's hypervisor type 1 or 2, you would still have to bundle the underlying operating system image and have some overhead to emulate that virtual machine, which would kind of an illusion of a physical machine. And those containerization tools help you to create virtualized environments, which are sort of lightweight virtual machines, very much in vogue with DevOps. Those tools are predominantly used on Linux platforms. Modern Linux kernel support the C group and namespace capability, which allows you to create those containers, some sort of an isolation of your space where you can deploy your applications. LXC, it's a Linux container which has its roots in research done at Solaris and before that. When you don't want to deal at this level of creating those lightweight containers using LXC, you can use Docker. It's an open source project that allows you to leverage all those benefits of the Linux kernel extensions to create that PaaS-like platform as a service like services, where you would be working at the level where you would just pull a particular application for a repository from that hub of certified and public domain images of various systems, such as I know, Redis, MongoDB, you name it. You can pull it down, install it, and in a matter of seconds to provision it. LXC and Docker don't give you that much of an isolation that you would have a virtual machine, but in many cases it gives you that peace of mind that things are really multi-tenant. You would run multiple containers on the same physical host machine, and you, by the way, can achieve much higher density of containers because they are much more lightweight. They have a smaller overhead, faster boot up or spin off time, and much smaller footprint on the physical hard drive. So it has lots of benefits at the expense of maybe some security concerns, like Docker runs its daemon at root account, and sometimes you might not have a very clear separation of that multi-tenancy partition might not be as kind of a guaranteed. So probably one rogue tenant can probably cause some trouble to other tenants. But people are experimenting, and whenever you want to build, for example, multiple build machines, or you would like to have different environments testing different versions of Java, different browsers and what's not, rather than using virtual machines like VM Player or something else, you can use those containerization tools, which would aid in your DevOps practice in your organization. IT automation becomes very important when your cluster or your supported sites, your infrastructure reaches a certain level of number of nodes or level of entropy where you would like to bring some order. Most of those configuration automation tools are built around that infrastructure as code model or paradigm, and I mentioned Puppet and Chef previously. So those tools really help you to create that seamless experience for managing large clusters. So Puppet, we saw an example of its code. A little bit more on that. It's an open source project written in Ruby. By the way, you can use it on not only on Linux but on Windows as well. Puppet comes with some of the tools that you can use in isolation that can help you to create inventory of your system resources. So take a look at this. It's domain-specific language, very basic, so you can learn it quite easily. The only thing is to understand the nomenclature of resources that it handles. You can get enterprise-level support from Puppet Labs. It's a company behind Puppet. They've got excellent documentation, but at a certain level, you would probably say, I would like to get experts support. Puppet Labs is the place to go. Chef is very close, and originally Chef was influenced by Puppet, and they used some of the tools. It was also written in Ruby, so which made that reuse more effective. It's more complex in setup. It has I guess RabbitMQ, which is based on Erlang, and sometimes it's probably worthwhile to spend some time to learn how to tweak all those parts of the deployment. Chef is considered to be more flexible by some than Puppet at the expense of being a more complex systems. Sometimes you have to pay. There is a balance that you should strike between ups and downs of a particular system. Continuous integration systems, I guess Jenkins, TeamCity, Cruise Control, you might use something else. Let's take a look at some of the systems. Jenkins, it's a Java-based open source continuous integration tool. Originally, it was based on Hudson, and when Oracle acquired Sun, Hudson was part of Sun portfolio. It was integrated with NetBeans as the IDE. And there was some, I guess, commotion, and the lead developer behind Hudson left Oracle and he joined Jenkins. Jenkins is It's an open source project. As Hudson is still available if you would like to use it, but I guess the more vibrant and more productive IT community is built around Jenkins. At its core, Jenkins is just Java Web Server, which accepts requests. It exposes the admin dashboard where you can configure your builds. You can invoke particular build on demand. You can get some statistics, reports. You can suspend things, do integration with version control systems, and configure other plugins. It's a powerful system. Costs nothing. In many cases, you would probably be happy to use that, and many people do. It integrates with Apache Ant and Maven. We are going to touch those build tools in a moment as well. TeamCity is another continuous integration tool, which is a commercial product. Sponsored by JetBrains. So JetBrains has lots of brains scattered over lots of things. So IntelliJ, for example, one of those products. If you would like to get a more exquisite experience, you can start using the free edition of TeamCity, and if it really meets your demands and fits your bill, then you can probably get a commercial license from them. You can have a free, I guess, edition with some constraints up to a number of build agents, which limits how effectively you can do the build. So probably it would be just a very sort of pet project, proof of concept, where you would like to give it a try. For those people who are not familiar with built-in dependency management tools, I'm going to touch those quickly. So Apache Ant and Maven, I guess one of those main players in this field. By the way, now that Codehouse is announcing its kind of demise, Codehouse is going out of business, ousted by GitHub and Bitbucket. And Maven is probably they have lots of plugins and repositories hosted by Codehouse, and Codehouse have been operating at a loss for some years, and they're no longer able to compete with GitHub and Bitbucket. So there would be some, I guess, problem in migrating all those repositories. Ant is an Apache product which is not really affected by that. I'm not going to spend much time. If you're not familiar with those tools, please spend some time. Even though they are oriented towards the Java world, you can do other things as well. You can manage your builds for other systems as well. Okay, so Gradle is another product written in Java and Groovy, and Groovy is Java-based language. Gradle is a more powerful system and more complex, but it is designed for managing complexity, taking the complexity out of managing or building and managing dependency of your large projects. It has some optimization built in, such as skipping part of the project which have already been built, and it has some heuristics. It's a very powerful system. By the way, Gradle is based on Groovy, and there is another development, recent one, where Pivotal announced the Spring Source originally. They stopped supporting Groovy. They just allocated enough funds to support 2 more major releases of Groovy and Grails, and after that they will cut off funding. I guess the lambda expressions of Java 8 played a very nasty role on Groovy. So one of that differentiating factor for Groovy was to use those closures, kind of a lambda expressions, and now Java 8 gives it for free. So Groovy probably would reinvent certain things. So Gradle is Groovy based. I'm just giving you that caveat of using Gradle. Okay, so Lisa, so the question is if I can download a copy of the slides. In the chat window, which you can detach from the GoToWebinar console, you can see that link. I published it there. IBM. So as I said, IBM has been pursuing that venue quite aggressively, and they have already got a great deal of expertise in managing the life cycle of applications, software delivery life cycle, application delivery life cycle, you name it, they're there. And they've got expertise, they've got the right people, they've got, I guess, all the contacts, access to, I guess, to those pools of talent where they can quickly create something which would meet the needs of the present-day enterprise. So they are now trying to formulate that new approach as a holistic discipline for collaborative lifecycle management, which is built around a combination of enterprise practices like requirements gathering management, quality of software product management, configuration management, and project planning and tracking. Of course, you can find all those tools in the open source space. It would be kind of maybe apples and oranges, but if you're interested, you would be able to build something from the open source projects, maybe with lesser quality, with more time, but definitely with much fewer bugs. It would be much less expensive. So that's how IBM sees the interaction between your business analysts, your BAs, your QA. It's a cycle which has loopbacks, feedbacks. I'm not going to spend much time on that. So IBM gives you a choice of tools, and one of the most prominent in this space are Rational Team Concepts, Quality Manager, DNG, and all those tools are bundled together, and they have that interoperability with one another, joining all those tools into one unified collaborative lifecycle management platform. So RTC gives you that collaborative environment which spans all those activities which are absolutely indispensable in your enterprise, like issue tracking, access to source control. Of course, it would be a plugin to, it doesn't really, it has its own, but you can use any of version control system that you would like to use in your enterprise. Project management, continuous build and integration, so it has all those aspects that we have touched upon previously. Originally, it had some kind of performance problems around some corner use cases, but I guess with latest versions, they have fixed those. By the way, you can experiment with RTC. You can download and use it up to 10 developers. Up to 10 users. The system is available for you, and it's a good start. So DNG is a requirements management solution which helps you to capture requirements, store, trace, manage. So all those quite needed activities in your requirements management area. You can also assess the impact of any application change. So based on that tracking of the original requirements, the system will identify any collision or any, it would identify those possible impacts that might result from introducing new changes. DNG has the built-in support for enforcing compliance with industry and other standards, as well as some applicable regulations. Okay, so that's it for our coverage. So we didn't have enough time to really go into all aspects of DevOps. It's a very, I guess, big area, and we just didn't even scratch some of the topics, such as like monitoring, alerting, and other more elaborate and arcane systems like process supervisors and things like that. But what we discussed in this webinar, some of the topics that you can probably need to start looking if you haven't done. One thing is to use cloud, and preferably use PaaS. If you're an IBM shop, take a look at IBM, Bluemix. And also explore that containerization ecosystem of tools such as LXC, Docker, Rocket was recently issued by a company which currently competing with Docker. And basically, you need to start thinking in terms of merging some of operational aspects with some of the development activities, and that would ensure that the quality of software and the velocity of delivery would be better, and that would be probably the ultimate goal. So I'm here to take your questions that you might have. Okay. So DevOps has been popularized by organizations adopting cloud as a service computing model. What do other organizations do? What are the impediments if you don't adopt the cloud computing model? I guess what I was trying to say is, first is definitely DevOps has become that hot topic when people have seen the success of Netflix and other companies. So that was the, I would say, the true value delivered right. It was the message. It was right on the money. Cloud as a platform, that cloud as a service gives you that experience where you can share. You can hide away the complexities of many of the tasks. For example, using Puppet and containers combined would allow you to provision resources just by using that infrastructure as code approach. Organizations can adopt their cloud-like environment on-premise without really going to the cloud. That's not the message that I'm going to get across. Cloud, the public cloud is one thing, but you can also create cloud-like environment on-premise behind your corporate firewall. And you can pursue that, and when because it gives you all the benefits of using provisioning on-demand services when you need them, as you need them, cloning environment, transferring those virtual machines across environments, and it would, the model itself, cloud as a service, helps you with that. For example, OpenStack is an open source cloud platform, can give you the benefit. Many companies are leveraging that platform to give their own offering. It's infrastructure as a service, but you can build on top of that your own PaaS. Eventually, you need to create that level of abstraction, which is cloud as a service, which would hide away or abstract some of the complexities of the underlying infrastructure management. That's my point. I guess eventually, it would be a seamless experience for you if you would decide to create a private cloud in the public cloud, then you would have the same experience, the same tooling, and you won't need to retrain your people. So that was the point. So what's the difference between Docker container and hypervisor, and any thoughts? Docker gives you a higher level of abstraction. It's OS level virtualization. It's, I guess, its main focus is on providing virtualized environments for your applications. It would be around that new concept of microservices where you would have a specific service, whether it's Tomcat server, Redis caching, or maybe MongoDB NoSQL system provisioned as in a container, which would be accessible from outside the world, which would have all the necessary capacity in terms of RAM and what's not. You can build a cluster of those machines. So that's what Docker container gives you. Hypervisor, it's actually virtualization virtual machine monitor. It gives you that level of, I guess, access to the underlying physical machine. So I guess Docker uses the Linux modern Linux kernel facilities of C groups and namespaces to access the kernel services without any need for virtualization for any hypervisors. So forget about like KVMs or Zen or things like that. It has like this virtualization environment is built, support is built in Linux, and Docker just reuses it. I guess that's the best I can, I guess, give in this period of time. The question is, my company is currently using 3D waterfall delivery, but is considering agile and DevOps models as well. Would like to understand when it would be best to use DevOps over waterfall or agile. I guess you can bundle DevOps with agile, and I guess waterfall at a certain point in time when you would probably start delivering stuff to testing, so it would be at a later stage. I guess DevOps, it's just a practice that can be bundled or bolt on or merged with both waterfall and agile. So DevOps is, if you kind of have seen some of the points that might not be very well articulated by me, it's just a way to help merge the concerns of development. So when development is done, whether it's agile or waterfall or any other model, the next logical step is to deploy and promote your code. And at this point in time, operations come into play and they say, you know what, don't just drop this WAR file or ER file or any bundles that you promote, that executable that you promote, just manually FTP in the file. There should be a script. And that script should be used for all the environments, start as early as possible. That would ensure the consistency of deliveries, the predictability, and you would use the same script to eventually promote that stuff maybe to staging. Maybe production would be a different thing, but the whole idea behind DevOps is to have the same seamless DevOps experience through every stage, and eventually that would be the same script promoting your code to production. So I would say you can start using DevOps. Start using it maybe on a smaller scale, and I would say not creating a full organizational structure for that with a single reporting system. Start creating a small contact group with probably best from devs and best from ops, where they can start collaborating. In many cases, it's not possible to create a very good face-to-face interaction because in our distributed development environment, we don't no longer enjoy the luxury of having people sitting in the same building or on the same floor. People are kind of spread over the globe, different countries, different continents. So see what you can do for yourself. But definitely DevOps is the way to go. And DevOps would come with containers, and containers would come with cloud. I guess you would probably be able to drive many of those concepts and new models, and forgive me for saying this again, paradigm. All those things, they would help probably reformat certain things and start taking a fresh look. And in many cases, platform as a service can help you right away. So another question is, can we have WebSphere on Docker? I don't think that WebSphere is currently available in the Docker. You can go to a Docker repository. It's a hub which contains images of all the applications. I have a very big doubt. And one of the reasons is that probably Docker or some other folks might have approached IBM, but IBM would say, you know, we've got a blue mix and we've got something in the makings that would probably oust Docker out of the enterprise space. I don't want to demonize IBM, but they have their own probably technology stack, and they're doing a great job. And in many cases, it would probably be the best in breed when particularly it comes with to application servers. Definitely WebSphere is one of those tools. Yeah, I understand what you mean, Sabir, but I guess I cannot really answer that question. But my guess is just do research for your own, but I have doubts. Okay, so I believe that's all the time we've got for today. Thank you very much for tuning in.